Good morning. This is Abisha Baslin, Assistant Professor in Triple Department, Himalayas at JJ College of Engineering. Now we are going to see a topic embedded processor Unit 1 for Triple Department. Introduction of ARM architecture. Founded in November 1990, spun out of Icon Computers, designed the ARM range of RISC processor cores, licensed ARM core designs to semiconductor partners who fabricate and sell to their customers. ARM does not fabricate silicon itself. Also developed technologies to assist with the design in of the ARM architecture. Software tools, boards, debug, hardware applications, software, bus architecture, peripherals, etc. A ARM processor derive their name from the acronym Advanced RISC Machines, signifying their connections to the broader family of CPUs and adhere to the RISC architecture. In essence, advanced RISC machines have laid the foundations for the architecture of ARM processors, giving them their distinctive name. The hallmark of ARM processor lies in their architectural simplicity, resulting in a compact size and reduced complexity. This inherent simplicity allows for optimal performance when integrated into a system, delivering high levels of efficiency. Introduction. Leading provider of 32-bit embedded RISC microprocessor, 75% of market, high performance, lower consumption, lower system cost. Solution for embedded real-time systems for mass storage, automotive, industrial and networking applications, secure applications, smart cards and SIMs. Open platforms running complex operating system. ARM v1, the first version of ARM processor, 26-bit addressing no multiply coprocessor. ARM v2, ARM2 first commercial chip included 32-bit in result multiply instructions coprocessor support. ARM v2a, ARM3 chip with a one chip cache added load and store cache management. ARM v3, ARM6 32-bit addressing virtual memory support. ARM processor core. Current low-end ARM core for applications like digital mobile phones, TDMI, T for thumb 16-bit instruction set, D on-chip debug support, enabling the processor to halt in response to a debug request. M enhanced multiplier yield a full 64-bit result, high performance. I embedded IC hardware. Von Neumann architecture, 3-stage pipelines. ARM core diagram. In this ARM core diagram, the instruction set in the architecture describes the function of each instruction and explains the representation of the instruction in the memory. Through encoding with the help of this instruction, it is easy to manage the architecture and the microprocessor. Priority encoders help to load the instructions and to store it in a specified register in order to manage the files. This helps to identify the registers and instructions easily in the architecture. Multiplexers are used in the architecture to manage the operation of processor buses. The components are instructed to work in behavioral mode and the components are implemented as an entity. The architecture of the entity is optimized depending on the application of the processor and helps to construct and maintain the design. 32-bit inputs are used in arithmetic and logic unit, which comes from register files and shifter. The outputs are modified in register file flags. There are C flag, V flag, S flag and Z flag. 16 opcodes can be implemented with the help of 4-bit function bus in the microprocessor. V bit output goes to the V flag and C output to the C flag and so on. Both multiplier factor has 32-bit inputs to manage from the register file. The output given is also 32-bit and multiplication starts when the input is actively working with the processor. Also, another multiplication rule is used in the system for choose complement numbers. The both algorithms manages both positive and negative numbers with the same importance and faster multiplication in performed by ignoring zeros and ones in the process. 16 clock cycle manages the multiplication cycle in the system. 32-bit input shifting is represented with the help of barrel shifter. The input is either from the register file or from the given data given by the user for faster output. Shift manages this with the help of different controls and also with the functionalities of the system. The logical and arithmetic operations to be performed is indicated in the shift field of the barrel shifter. The quantity is mentioned in the instructions field and it can be as low as 16 bit in the register. It allows up to 32-bit file and responds to left, right, arithmetic right and rotate right shift. This works well with multiplexers in the microprocessor. Control unit controls the entire process of the architecture and manages the system operation. It can be made of circuits or can be combinations of functions and circuits in the design. Timing is managed in the control unit and works with a combination of state machine in the processor. The operation in the processor is managed and controlled with the help of signals from the control unit as these are connected with different components in the system. There is a register set in the architecture to help in managing the registers with their corresponding time in the structure. It is important to check for the number of registers and the size of the same for the proper functioning of the system. The function of registers is to manage the files and keep them in the proper place and check for their initial state in the processor. The expansion model in the architecture helps to know different level of access provided in the system and the types of exceptions in the system. When the exception is accepted, the changes undergone in the system are also noticed. Breakpoints are noticed and information is captured with the help of trace points. The registers. ARM has 37 registers, all of which are 32 bits long. One dedicated program counter, one dedicated current program status register, 5 dedicated save program status register, 30 general purpose registers. The current processor mode governs which of several banks is accessible. Each mode can access a particular set of R0 to R12 registers, a particular R13 the stack pointer SP and R14 the link register. The program counter R15, the current program state register CPCR SR privileged modes except system can also access a particular SPSR saved program status register. Different states of registers. When the processor is executing in ARM state, all instructions are 32 bits wide. All instructions must be word aligned. When the processor is executed in ARM state, all instructions are 32 bits wide. All instructions must be half word aligned. When the processor is executing in Jessel state, all instructions are 8 bits wide. Processor performs a word access to read 4 instructions at once. Thumb is a 16-bit set optimized for code density for C code. Improved performance from narrow memory subset of the functionality of the ARM instruction set. Core has additional executive state thumb. Switching between ARM and thumb using BS instructions. For most instructions generated by compiler, conditional execution is not used. Source and destination registers identical. Only low registers used. Constants are of limited size. Inline barrel shifter not used. ARM interface signals. The ARM interface signals consist of clock control, configurations, interrupts, initialization, bus control, debug, coprocessor interface, power, memory interface, MMU interface, state, tap information, boundary scan, extension, JTAG control. It is ARM 7 TDMI core. ARM interface signals, clock control, all state change within a processor are controlled by mclock, the memory clock, internal clock, mclock and wait. E-clock output reflects the clock used by the core. Memory interface, 32-bit addresses, A30.0, bidirectional data bus, separate data out, data in, D in. Second indicates that the memory address will be sequentially to that used in the previous cycle. Interrupt. Fast interrupt requires higher priority. Normal interrupt request async allows the interrupt signature to be passed. Initialization. Restart starts the processor from a known state executing from address. ARM characteristics. The memory access a ARM is a von Neumann load store architecture that is only 32-bit database for both inst and data. Only the load store inst access memory. Memory is addressed as a 32-bit address space. Data type can be 8-bit types, 16-bit half word or 32-bit words and may be seen as a byte line folded into 4-byte words. Processor core vs CPU core. Processor core, the engine that fetches instructions that execute them. Example: ARM 7 TDI, ARM 9 TDI, ARM 9ES. CPU core consists of the ARM core processor core and some tightly coupled function blocks, cache and memory management blocks. Example: ARM 7 OT, ARM 720T, ARM 74T, ARM 920T, ARM 922T, ARM 940T, ARM 946ES and ARM 966ES. Thank you.